act up the incline. Then there's a radius r. Sorry, one more thing. Let me show all the forces. mg sine theta, mg cos theta, and this is the normal contact. In fact, there's a slipping is there. So because of that, the friction will act here now. Okay, let's come for, he has given mu equal to 1 by root 3. Let's calculate all. So what is Fk equal to, what is N equal to? Mg cos theta, perpendicular to inclined plane, N minus Mg cos theta equals 0. So what is Fk is equal to? Mu N, it's not a rolling friction, it's kinetic friction. Not a rolling friction, but sir, you only said rolling friction. Look at the condition, given angular velocity and released. So mu k, this will be mu mg cos theta. So let's calculate this value of this one. This is mu equal to how much? 1 by root 3 mg cos theta, cos 30, root 3 by 2. How much we are getting? Mg by 2. How much of mg sin theta? So what is this? This should be equal to. This should also mg by 2. So in fact, what's happening is Fk minus mg sin theta equal to 0 along the incline. Huh? So what's happened to net force on this spinning cylinder along the incline will be 0, that one, along the incline. So therefore what happened, that one, no acceleration along the incline. Then only because of friction acting, there will be an anti-torque. Angular acceleration will act here. Alpha O will write it. How to calculate that torque? Fk into R should be equal to IO alpha O. Fk is what? Mu mg cos theta into R. I think already we know Fk value. If you want to substitute, so this shall we call retardation? Why retardation? Because how do the kinetic friction, it will set up a torque. This is R bar, this is Fk. It will set up anti-torque, no? And angular velocity is given is clockwise. The torque is set up anti-clockwise. So why not torque due to weight? It will intersect axis of rotation. About O, the torque is set up by only kinetic friction. About O, this where we are defining about O. Okay, let's calculate this one. So this everything should be mg. So what is the value of Fk? Fk equal to mg by 2. I'll write it. So again y2. So r get cancelled. So what is alpha naught is equal to g by r. Can we calculate now the time taken for the angular velocity to become 0? 0 equal to omega naught plus alpha naught t1. So what is t1? T1 is equal to, so what you should comment this t1, time taken for the cylinder only to spin. It will not slide, it will be there only. Time taken for the cylinder to spin. It will not slide here. Time taken by cylinder to spin. Without sliding, without sliding along incline. I think this comment is very important. Now, once after this time, this is t equal to 0. This t equals 0. So what will happen to this particular? So once omega becomes 0, then what will happen? Then once omega becomes 0, it starts sliding. No, when it starts sliding. So what is the time taken by it to reach the bottom of incline? It will reach the bottom of incline with a velocity v and omega, and this is the time t equal to t1, and to slide what will happen, it will take a time to t2. So how to ensure that it will have pure, no slipping or pure rolling occurs when it's sliding down the incline? Any condition? Because there is a slipping occurs between point P of the disc of the cylinder and the inclined plane. So therefore kinetic friction. So it will only rotate there. It will not slide because the net force along the incline is zero. Okay, now after this, once angular velocity has become zero, then what happens? Mg sin theta force will act. Then here now rolling friction will act here. Now rolling friction will act. Then center of mass will accelerate, call A naught. Then this friction will set up a torque, alpha naught. So some other better will call only alpha, that one here. And this is a strictly rolling friction. Now, sir, how do you can say that no slipping occurs? What is the guarantee? Tell me what I should do. Whose help I should take? And what is the minimum value of mu for no slipping to occur for a solid cylinder? Solid cylinder or disc, both are same. Can you recollect morning we have discussed what should be the minimum value of mu for no slipping to occur? That's what, see, like, if you remember some data, it'll be much more useful for you. What should be the minimum value of mu? Minimum value of mu required for no slipping is how much? Tan theta by 3. Tan theta by 3. Morning we have discussed, no? Can you hear me? Shall I continue?
Yes, sir.
I
Yes,
think yeah,
sir.
power gone. With mobile will manage things. No. Anybody morning? Shall we say minimum value of mu? Mu minimum. Morning we derived, no? Anybody please check. Anybody? I think I won't. Tan theta by 3. Okay, fine. Yeah. So what is the minimum value of mu? Tan theta by 3. Okay, what is the mu given? Let's check what is mu given 1 by root 3. Okay, will it satisfy? So let me substitute here tan 30. Please do understand it's a very good problem. Tan 30, value of tan 30, 1 by root 3. The mu of the inclined plane is 1 by root 3, but minimum value of mu needed for no slipping how much? 1 by 3 root 3. So the mu is greater than mu minimum or less than mu minimum? Is in fact greater than mu minimum. This is very important. Please try to understand the concept which I am trying to reflect here. So therefore what happens? If the mu of inclined plane greater than mu minimum, what happens? Slipping will occur or pure rolling will occur. What will occur? If mu of inclined plane less than mu minimum, then slipping will occur. Whatever you do it. If the mu of inclined plane is greater than mu minimum, then what happens? Pure rolling will occur. So therefore here, pure rolling takes place. Got the idea? How to utilize this morning what we discussed? How to use that concept is this one. This is very important. So in every numerical, please do. I think it's all about in exam you can't derive this. Are you getting no? I asked you to remember something. What should be the minimum value of mu for a ring, for a disc? Ring or hollow cylinder, both are same. Disc, solid cylinder, both are same. Solid sphere, hollow sphere. That particular equation you remember. In exams directly you can start. Otherwise what happen, you should search, you should derive this, then you should enter problem. It'll become very lengthy. Getting some? So I'm trying to give you some help here. You should remember all this data. Okay, now let's come. So pure rolling will occur. So what is the time taken? So can we calculate expression for acceleration? So what are the formulas? mg sine theta minus f equal to ma. Then f into r is equal to mr square by 2 into alpha for pure rolling. So now you can write pure rolling on what basis? Yes, the mu is greater than mu pure rolling. Solving this r alpha, I'll write it. This will be f equal to ma by 2. R alpha I'll substitute here. Then R also I'll cancel out. Then I'll get f. This value of f I'll substitute there. mg sine theta minus ma by 2 equal to ma. So what is a is equal to 2g sine theta by 3. Now what is the height of the inclined plane given? H. You try to 3r it is given. So what can be the distance? What can be this distance? So here what is the overall distance it has to slide from year to year? What is the time taken? And I think I'm helping with almost all what actually going on here. I know how to calculate this T2. For that we need X, and for that what is given? This height is 3r given. And we know this theta. So sine theta is equal to 3r by x. So x equal to 3r by sine theta. Theta is how much? 30 degrees. So therefore this will be 3r 1 by 2, 6r. Then what is the time taken? We know acceleration, we know the distance. So x is equal to a t2 square by 2. So 6r 2g sine theta by 3 t2 square by 2. So all this you'll get the value of t2. Then what is the total time taken by it? T1 plus t2. By the time it reaches here, t1 is the time taken. What is the t2 you should call? What is t2? Time taken to roll down the incline. What is the t1? Time taken for they to spin there only. It will first only spin, then afterwards. So I think two frictions are there. There's a really very good problem I'm telling this one. First it will only spin. Angular velocity decreases. First it will be like this. Then able to understand the problem. First it will only have spin, means it will only rotate there. Why can't slide down? Because fk equal to mg sin theta. So it'll be like this. Then so two times are there, no? T1 and T2. Please do, these are some very basic fundamental problems which you should, with respect to inclined plane.
Sir,
Yeah.
Sir, the mu what you gave, sir, is it the static frictions mu, sir?
Which one, ma'am?
1 by 3.
1 by 3? Yes, it is a mu, static friction only.
So then, I mean, static and kinetic friction are balancing each other, right?
Here mu, see, like when
sorry,
I don't...
Static and mg sine theta, sorry.
The problem here is like the mu, what happened when I don't mention anything? I think mu is equal to mu k. Finish over long back we outside. No. Why you are troubling yourself with unnecessary thoughts?
Sorry, sir. Yes, sir. Understood.
Nothing to do that one. Just say, if I write mu s or mu k, then we could have debated. I didn't mention anything. Finish over. So mu s equal to mu k. Depend upon the condition. If the body is sliding, still you can write same thing. If body is at rest, then static friction will not come mu, no. Static friction should be equal to mg sin theta. Here, the kinetic friction is becoming equal to mg sin theta. I should not call this as static. I think there's a I'll be killing the total friction chapter if I call this static, because slipping occurs. It's a kinetic. Okay, after this, okay, now we'll go back to a few more